The Continental Drift Theory, the story of our moving continents. Hey everyone, welcome back to my channel Lane. Today we're diving deep into one of the most fascinating ideas in Earth science history, the Continental Drift Theory. Have you ever wondered why South America and Africa look like two pieces of the same jigsaw puzzle? Or how the gigantic Himalaya mountains were formed? Stick around because this story reshaped the way we see our planet. Section 1. What is continental drift? Continental drift is the concept that Earth's continents have not always been fixed in their current positions. Instead, they've moved very slowly across the surface of the planet over millions of years. Imagine continents as enormous rafts floating atop the Earth's semi-fluid mantle, driven by powerful forces beneath. The theory says that hundreds of millions of years ago, all landmasses were fused together as a colossal supercontinent called Pangaea. Over time, this massive land split apart, and the pieces drifted to become the continents we recognize today. Section 2. The birth of a radical idea. The person most credited for championing continental drift is the German scientist Alfred Wegener. In 1912, Wegener boldly proposed that the continents are not static, they move. He named the original supercontinent Pangaea, suggesting it started breaking apart around 250 to 200 million years ago. Before Wegener's theory, scientists thought that continents and oceans stayed exactly where they were forever. Wegener's hypothesis was revolutionary, but also controversial. Many scientists rejected it at the time because Wegener couldn't explain exactly how continents moved. Section 3. Evidence for continental drift. What made Wegener so convinced? Jigsaw fit. Just glance at a world map. Coastlines of continents like South America and Africa fit snugly together as if once united. Fossil clues. Identical fossils of extinct plants and animals, like the Mesosaurus, are found on distant continents separated by vast oceans. How could a freshwater reptile swim across the Atlantic? Rocks and mountains. Similar rock formations and mountain ranges exist on continents now oceans apart. For example, the Appalachian Mountains in North America and the Caledonian Mountains in the UK and Scandinavia. Glacial evidence. Signs of ancient glaciers are found in now tropical places like India and Africa, suggesting these lands were once connected near the South Pole. Section 4. Why was Wegener's theory rejected? So why didn't Wegener's idea catch on instantly? The biggest hurdle, he couldn't provide a convincing mechanism for how such gigantic landmasses could move. Many scientists just couldn't picture continents plowing through what they believed was solid rock underneath. It wasn't until the 1950s to 60s, decades after Wegener's death, that new discoveries like seafloor spreading, convection currents in the mantle, and precise GPS measurements proved that Earth's crust is indeed in motion. That's when the theory of plate tectonics was developed, fully explaining and expanding on Wegener's original idea. Section 5. The impact of continental drift. Why does it matter? The acceptance of continental drift revolutionized our understanding of Earth. Here's why it matters. Mountains and oceans. The movement of continents explains how mighty mountain ranges and deep ocean basins are formed. The Himalayas, for example, are still rising as India continues to collide with Asia. Earthquakes and volcanoes. Most earthquakes and volcanoes occur along plate boundaries, where continental drift is most active. Climate and evolution. The drift of continents has changed ocean currents and atmospheric patterns, shaping Earth's climate and influencing the evolution and distribution of plants and animals. Minerals and fossils. The breakup of continents explains why similar fossils and valuable minerals are found on different, now distant continents. Section 6. Modern proof continents still on the move. Today, we can use satellites and GPS to directly measure how fast continents move, usually just a few centimeters per year, about the rate at which your fingernails grow. So Earth's surface is far from static. Our continents are always on the move. And there you have it, the incredible story of continental drift, from a wild idea to a foundation of modern science. If you learned something new, smash the like button, subscribe for more amazing science stories, and let me know your favorite moving continent fact in the comments below. Until next time, keep exploring. Thank you for watching, like, share, and subscribe.